Hello everyone, welcome back to Diksha Karnataka YouTube channel, and today I am going to bring you a very special treat, that is all numericals, all important numericals that is going to come in your PU exam, second PU exam basically. And here we have covered all the aspects and only 20 numericals I am going to suggest you. If you solve all the 20 numericals, then you can answer the questions that is going to come in your PU exam. I will suggest few chapters, so don't waste your time if you have not studied the entire numericals. I know many of you are struggling with numericals. Sir, what will happen to a numerical? I have completed the theory part. What should I do about the numericals? So this is the video where I am going to discuss all the important numericals. So without any delay, let's start with today's lecture. How many questions are coming for numericals? Previously there used to be 5 numericals, you have to answer 2. Now they have reduced the number, now 4 numericals you have to answer 2. So 50% option is there and you get 10 marks full, okay, if you correct them properly. And don't worry if you even if your final answer is incorrect, if you have done the problem in a correct approach, then still you can score up to 4 marks. Final marks, final number only has 1 mark in it, okay. So don't worry, try to approach the problem even if you have not solved any numericals. Also I request you to watch this video at least twice if you have not solved any numericals, okay. Now from where we should study the numericals from, there are at least 6 to 7 chapters from where the numericals is going to come, but I am going to suggest electric charges and field, electric potential and capacitance, alternating current and ray optics. These are the 4 important chapters from where you can expect numericals. Now out of that, alternating current and ray optics numericals are generally considered to be HOTS question, but trust me, they are not that as hot as you think. They are very cool questions. Current electricity is another chapter from where you can expect one numerical, but that question is generally very difficult for a normal student. If you have not practiced circuit theory, you have not solved a lot of numericals from circuit theory, then do not attempt circuit theory at this stage. That will be detrimental, that will be very bad for your score, okay. Even though the problems are simple, means solvable, but that takes a lot of time to solve and you need a lot of practice. At least 30-40 different types of problems from current electricity you have to practice to get that marks, okay. You have to practice. The pattern is same, but practice is more important because many students make small mistakes and that led to complete disaster of that chapter. So don't try to solve that chapter. And if you have no time, then these 2 chapters are very important. Almost all the blueprints are having questions. Alternating current is definitely one chapter. At least alternating current, if you do, you can solve 5 questions, no doubt. You can score 5 marks. You can score 1 question, 5 marks. Ray optics is the second chapter from where if you study, you can score another 1 marks, but sometimes ray optics questions are slightly difficult. So that is why I am suggesting these 2 chapters. These 2 chapters are very straightforward, easy chapters, and from these 2 chapters combined, you can expect 1 numerical. Okay, so that is why these 2 chapters are, if you are studying, you have to study both the chapters. You cannot study 1 chapter here. But alternating current, on the other hand, if you study, you are expected to get 1 question. Ray optics also you are expected to get 1 question. So 2 questions from here, 1 question from here. So total 3 questions I am preparing for you. In case one of the question is little harder, then you can still solve 2 numericals. That is why you have to have at least 1 extra option. Okay, the 4th question will be from the current electricity, that you do not need to study if you are starting right now. Also, one more important fact, I am going to solve 1 bonus question from your model paper, which is from the chapter dual nature of light and matter. There is only 1 blueprint with the question from that chapter. I thought, okay, maybe if they give you an option, the same question comes in your final paper as well. So I will be solving that as a bonus at the end of the video. So don't forget to watch that as well. Stay with us. in this 2.5 hour lecture, I am trying to complete all the important numericals that is going to come in your final PU board exam. So first start with the electric charges and field chapter. First question, consider a uniform electric field E equals to E into 10 to the power of 3 I cap Newton per coulomb. So electric field is given here. Okay, let me write it down whatever is given. 3 into 10 to the power of 3 Newton per coulomb. Okay, so what is the flux for this field through a square of 10 centimeter on a side whose plane is parallel to YZ plane? So that is why they are trying to make the question complicated. So what is the plane looks like, what is the electric field looks like? So we have electric field like this. Suppose this is x-axis, so electric field is along x-axis, right? We know that electric field is along x-axis because I cap. Now suppose this is my y-axis, okay, and sorry, not this way, y-axis should be inner way. So this is my y-axis and this is my z-axis. This is a three-dimensional figure, so generally we cannot draw a three-dimensional figure properly on a two-dimensional plane, but I hope you are understanding that y is into the paper. Now YZ plane means, what is the meaning of YZ plane? This is a YZ plane. Okay, this is a YZ plane, 10 centimeter of size, so 10 centimeter from both sides. Okay, so what is the electric flux through that? Electric flux is defined by electric field into area. Okay, simple as that, but it is a dot product. So if you are using vector sign, then you can do this way, and you can say that it's like EA cos theta. Okay, now in this case, when it is making it is along YZ plane, the angle obviously is theta equals to 0 degree. So cos 0 is 1, right? So when it is along YZ plane, that is the meaning of YZ plane. So first case number A, theta equals to 0. Okay, theta equals to 0, so the electric flux is given by EA. Only EA. You have to calculate the area, multiply it and get the value. As simple as that. What is area, by the way? Area is 10 centimeter. Now I told you 10 centimeter, always convert centimeter into meters, and to do that always use 10 to the power of minus 2 as multiplier. So this is 10 centimeter, this is 10 centimeter, but we have converted them into meters, so it is now meter square. So first check, have I converted all the units into SI unit or not? Very important. Okay, except problems in ray optics, all other cases you have to check if you have converted your units into SI unit or not. That is where student makes mistakes. They multiply 10 into 10, get 100 centimeter square, forget to change it to meter square. That is the major problem. So if you multiply, you will get 100 into 10 to the power 4 minus 4, that is 10 to the power of minus 2 meter square. So this is the area. Now what is the flux? Then flux is basically electric field is given 3 into 10 to the power of 3, and area we have calculated 10 to the power of minus 2. So flux is Newton meter square per coulomb. Okay, Newton meter square per coulomb. Unit is very important. Okay, so what is the value then? So 3 into 10 to the power of 3 into 10 to the power of minus 2, that is 3 into 10 only. 3 into 10, that is 30 Newton meter square per coulomb. By the way, if you want to get the PDF, join our WhatsApp channel. All the important PDF notes will be shared in our WhatsApp channel. So definitely you have to join our WhatsApp channel if you have not yet joined. So there I will be sharing all the PDF notes. The link for the WhatsApp channel is given in the description. So this is the first part. Now there is another question. What is the flux through the same square if the normal to its plane makes an angle 60 degree with the x-axis? Now the theta, case B, theta is basically saying that they are making an angle 60 degrees. That means theta is 60 degrees. As simple as that. So phi is basically equals to EA cos 60 degree. Now EA we have already calculated, that is 30. So EA we have already calculated 30, and cos 60 is what? Cos 60 is half. So half Newton meter square per coulomb. So it will be 15 Newton meter square per coulomb. So for unit, if you miss the unit, they will deduct marks. Now based on the examiner, it can be 0.5 marks, it can be 1 mark. Okay, so they will deduct, definitely they will deduct mark if you don't write the final unit. And if it requires the diagram, then you have to draw the diagram as well. For example, in this case, diagram is optional, it is not super necessary, so you can skip the diagram. But for your own understanding, if you are drawing the diagram, the examiner will know that you have solved this question on yourself. Okay, so don't try to mug this question. You have to understand the theory, you have to understand how it is solved. So that is what important. The same exact problem will not come, but the concept related to electric flask, how we are doing electric flask, maybe Gauss's theorem. Okay, in case of Gauss's theorem, the same formula can be used. We will solve one question on Gauss's theorem as well, that is Q enclosed by epsilon naught. Okay, from there you can find the charge as well. Okay, so that is how you can learn more about solving problems. Next, let's see the answer. So 30 Newton meter square per coulomb, 15 Newton meter per coulomb. So we have solved both the questions, and after solving the answer, you have to underline or box the final answer so that the examiner can see what is your final answer for the problem. Okay, now next question. 2 point charges QA equals to 5 microcoulomb and QB is equal to minus 5 microcoulomb are located at A and B separated by 20 centimeter in vacuum. Okay, what is the electric field at the midpoint O of the line joining the two charges? So basically this is like a dipole, but not dipole because the distance is little higher. Okay, so we have two charges. One is plus 5 microcoulomb. Micro means 10 to the power of minus 6. So micro, nano you have to be familiar with. So again, this is charge A, and charge B is 5 into negative 5 into 10 to the power of minus 6 coulomb. Okay, so this is QA, this is QB. Now how to tackle this problem? So here we have the distance between them is given 20 centimeter. 20 centimeter can be converted easily into meter by dividing by 100, that is 0.2 meter. Okay, if you are confused, you can multiply with 10 to the power of minus 2 as well. Okay, because some people, I have seen students, they get confused while multiplying 0.2 into 0.2. Okay, there are certain cases, if you are confused, use 10 to the powers. If you are confident, okay, I can solve it using just dividing by 100 first stage itself, that is also fine. The total distance is 20 centimeter, so this distance must be 10 centimeter. So this will be also 10 centimeter. Why we are doing this kind of thing? Because when two charges are given and you are asked to find the electric field, very careful, electric field. How to find the electric field? To find the electric field, first we will use one single charge. We will forget the what is the second charge is. For this charge, we will find the electric field and its direction. So if you see, the electric field due to this will be, this is a positive charge, so electric field will be away from this. So this is the charge due to positive, so this is electric field A. Okay, now if you consider the negative charge is basically electric field will be towards the charge. So we are finding the electric field at the midpoint, right? So electric field due to this charge will be towards it, so it will be EB. So both electric fields are in the same direction. Very, very important. In case if you find that electric field are opposite direction and equal, so they will cancel each other. If they are unequal, you have to add them based on who is greater. So while finding the electric field, the direction is very, very important. Okay, the sign of the charge does not matter. Sign of the charge only helps you to find the direction of electric field. So I always say that when you are calculating electric field, the sign of the charge is not important. Important is the direction of the field. Whereas when you are finding the electric force or electric potential, in those cases sign of the charges is also important. Okay, but in case of electric field, sign of the charge is not important, the direction of the field important. The sign of the charge gives you the direction of the electric field. Do not put negative sign while calculating the electric field, okay, because you have already know which direction it is acting on. So the midpoint is O given in the question, so O, so both electric fields are along OB. So this is a vector quantity, so you have to mention the direction as well. Now what is the electric field due to A at O, right? So electric field at A, EA, is basically given by K QA by R square. Now what is R in this case? So be careful, R is not 20, R is 10 here. Both cases R is 10. Okay, so K is 9 into 10 to the power of 9, QA is 5 microcoulomb, 5 into 10 to the power of minus 6, and the distance is 10 centimeter, that is 10 into 10 to the power of minus 2 whole square. Okay, simple step. So now find EA. EA will be 5 9s are 45, 5 9s are 45, and then 10 to the power of 9 into minus 3, that is 45 into 10 to the power of 3, right, divided by, if you see this will be 10 to the power of minus 1, right, 10 into minus 2 whole square. So this can be written as 45 into 10 to the power of 3 divided by 10 to the power of minus 2. So if you multiply it, you will get 45 into 10 to the power of 5, right? So this is the electric field due to EA. Similarly, electric field due to B will also be the same value. Okay, electric field due to B will also be the same value. Why the same value? Because both of the charges are same, but it is along OB. Along OB. Similarly, it will also be the same value. 10 to the power of 5 along OB. Both of them are along OB, and both, if you see, both of them I have kept the sign positive because I am relying on the direction and not the sign of the charges. Okay, so total electric field E net is basically addition of these two, EA plus EB. Okay, now since both of them are in the same direction, we can simply add them. It will be 90 into 10 to the power of 5 along OB. This is the resultant electric field for the first case. This is the answer for first case, and also you have to write the unit. So what is the unit for electric field? Unit for electric field is Newton per coulomb, and it will be along OB. Okay, next is, if the negative state charge of magnitude 2 nanocoulomb is placed at O, what is the force experienced by the test charge? Okay, so if you keep a negative test charge of minus 2 nanocoulomb, okay, negative test charge will experience a force opposite to that of the existing electric field. So it will be along OA. So the force will be along OA, and the magnitude of the force is basically given by Q into E net. Okay, and what is the charge? You have kept the charge 2 nanocoulomb. So 2 nanocoulomb means 2 into 10 to the power of minus 9, and what is the net charge, net electric field? It is 45 into 10 to the power of 5, right? So it will be 90. Sorry, it will be 90 here only. It will be 90, my mistake. So net electric field is 90, so it will be 90. So 90 into 2 is 180 into 10 to the power of minus 4, or you can say 18 into 10 to the power of minus 3. Okay, and unit will be Newton, and direction will be along OA. Okay, so direction, sometimes in the question paper I have seen they do not generally mention dimension, but if you mention the dimension it will be very good. The examiner will be very pleased if you put the directions as well. So let's see the answer. I think some answer values are wrong. Okay, it will be 9, not 9000, it will be 9 t into 10 to the power of 5, that is 9 into 10 to the power of 6, okay, Newton per Coulomb, right? In case I made any mistakes, don't forget to make the comment in the below, but I don't think I have made any mistakes. Maybe the problem was solved using this one as nanocoulomb. Okay, in case of nanocoulomb, the 9000 I think is the correct answer. Okay. Now, next question, we have launched Abhyas KCET test series, and if you are currently preparing for KCET as well as PU board, then definitely you want to take this offer, which is basically priced as 1499. In this 1499 it includes the Abhyas KCET test series of 1498 and your PU2 PU2 test series, that is for only available ₹1. What you will get in this test series? You will get total 35 of tests. Out of that 31 is paid, and 4 free tests you can avail right now by registering, given in the link below. Okay, and once you register you will get a link of the app. Through the app you can download the app and you can start answering the questions. It is available after your free tests are over. From 17th of March onwards we will be giving you KCET test preparation series, where you can get the question paper almost every day and you can answer it. We will come to clear all the doubts that you might have on the respective subjects, so everything will be done. Then we will have a detailed video solution for all the questions. We will have chapter wise revision videos. We will have chapter wise analysis of last 5 years of previous year questions. So everything you will get if you buy right now from our channel. Okay, so 2-point charges of +2 nanocoulomb and +6 nanocoulomb are placed at the points A and B respectively, separated by a distance 0.2 meter in air. Now if you observe here, the distance itself is given in meters. You might find question where they mention the same question but they ask 20 centimeter in air, so you have to be careful, convert it into meters before proceed. Now to 0.2 meters in air, find the magnitude of the resultant electric field at the midpoint O of the line joining A and B. What will be the magnitude of resultant electric field O if +4 Newton is +4 nanocoulomb is added to +2 nanocoulomb charge? Now if you see, it is almost similar to the previous problem, but in the previous problem we had two equal and opposite charges. Here two charges are different and they are having different magnitudes. Okay, so both of them are +2 nanocoulomb. Nanocoulomb means 10 to the power of -9, and this is 6 nanocoulomb, so 6 into 10 to the power of -9. Okay, and say again, this is A, this is B, everything is same. Okay, only thing is in this case you have to calculate the electric fields separately. Last case, because both the charges magnitude wise they were same, we have considered that we had only calculated EA, EB was equally same, right? Now what is EA here? EA will be away in this direction and EB will be in this direction. Why so? Because this is positive charge, so positive charge will repel, and this is also positive charge, this will also repel, so both are opposite direction and definitely they are not equal in this given case, right? Both charges are positive, so electric field will be away from for both cases, and as you can see, midpoint means 0.1 meter. This will also be 0.1 meter. Okay, midpoint means 0.1 meter, 0.1 meter. If you draw this diagram, you don't have to write too much all the given data. This is sufficient for explaining the teacher. Now again, first we will calculate EA. What is EA? EA is nothing but KQA by R square. What is K? 9 into 10 to the power of -9. What is QA? QA is 2 into 10 to the power of -9, and what is R? R is 0.1 whole square. Okay, so what is the value here? 10 to the power of -9, 10 to the power of so I made a mistake here. K will be 9 into 10 to the power of 9, right? So this -9 and +9 they will cancel, so we get 18 18 divided by 0.01, which is nothing but 1800 Newton per Coulomb. Direction is along OA. Direction is along OA. Okay, now what is EB here? EB, again we can directly write 9 into 10 to the power of 9 into what is the value? 6. 6 into 10 to the power of minus 9 by 0.01, that is 5400 Newton per Coulomb, and this is along OB, right? No, sorry, EA is along OB, and B is along OA. Sorry, extremely sorry. So it will be along, if you see that I have drawn the diagram correctly, so EA is basically along OB and EB is along OA. Now who is greater? Both of them are in the opposite direction, right? Both of them are in opposite direction, and greater one is this one. So the net electric field is definitely going to be EB minus EA, and the direction will be along OA. Okay, so like you have done addition of negative numbers, so what you do in negative numbers, you subtract the bigger number from the smaller number, and the direction is along the bigger number, right? Same here as well. So 5400 minus 1800 Newton per Coulomb, that is equals to 3600 Newton per Coulomb. So this is the electric field at point O, and the direction is along OA. Okay, so this is the direction, very simple as you can see, and this is I think came in last year question. So this is a very simple step by step follow up. If you solve it, you can get full marks, and it is not too long as well. Next part is what will be the magnitude of the resultant electric field at O if plus 4 nanocoulomb is added to plus 2 nanocoulomb charge. So in that case, QA, new QA will be plus 2 nanocoulomb was already there, and you have added another 4 nanocoulomb. So total charge will definitely be 6 nanocoulomb. So both charges QA dash and QB dash both will be plus 6 nanocoulomb. So the electric field, the resultant electric field will be 0, because EA and EB both will be same magnitude wise, right? Both are same, so you can see that both of them are equal. So electric field EA dash will be equals to EB, right? And what will be the net electric field? EB minus EA dash. Both are opposite direction, both are positive, both are equal, both are opposite direction. So basically they will cancel each other, and the net electric field will be 0. Okay, so this is the answer, 3600 Newton per Coulomb, and 0 Newton per Coulomb is the answer for question number 3. Next question, two positive charges of 0.2 microcoulomb and 0.8 microcoulomb are placed at a distance of 0.15 meter apart. What point on the line joining them the electric field is 0? So this is almost similar question, but there is a catch that we have two positive charges, plus 2 and plus 8. Plus 0.2 and plus 0.8. Okay, so let me draw it here. We have two charges. One is plus 0.2, another one is 0.8. Both of them are plus. Okay, and both are microcoulomb. Microcoulomb means 10 to the power of minus 6. Right now, the distance between them is 0.15 meter. So distance is basically 0.15 meter. Okay, now what will be the point lining joining the electric field is 0. So how can we calculate that? So if you see that this charge is bigger, this charge is smaller, and both charges are positive. If both charges are positive, the null point or the 0 point is basically located between the charges. If one is positive, one is negative, then the null point is basically outside the line joining the charges. Okay, so be careful about this. So both charges are positive, so null point say, and it will be closer to the smaller charge. So null point say at a distance x meter from the smaller charge. So what will be the distance from the bigger charge? From the bigger charge it will be definitely 1.15 minus x, right? So let the distance from the smaller charge be x meter. Okay, now what will be the electric field due to this EA and EB? Now in this case distances are different for both charges. So EA is basically, EA is this direction, EB is in this direction, right? Both are positive charges. So EA is equal to KQA by x square, or you don't need to put any values at this stage. Okay, don't put any values at this stage. You just write EA and EB. EB, so this is A, this is B. EB is KQB by 0.15 minus x whole square. Okay, don't put any values at this case. Now we know that electric field, net electric field is 0 at, say this point is P. Okay, at P. Therefore both electric fields must be equal and opposite. Okay, so magnitude wise electric fields must be equal and direction wise they must be opposite. So EA must be equals to EB. So let's calculate what will happen if they are equal. KQA by x square equals to KQB by 0.15 minus x whole square. Okay, so that is why I told you do not put the values, because they will cancel, and if you see lot of things, other things will also cancel. 0.2 into 10 to the power of minus 6, that is the first charge, divided by x square is equal to 0.8 into 10 to the power of minus 6 by 0.15 minus x whole square. So this will cancel, 10 to the power of minus 6 will cancel, the decimals will cancel. Okay, these two will cancel, and it will get 4. So 1 by x square is basically 4 by 0.15 minus x whole square. Okay, sir, we have solved up to this point. Now what? Now what you have to do? You have to take the square root on both sides. So if you take square root on both sides, on left hand side you get x. Okay, and on the right hand side you get 2 by 0.15 minus x. Okay, is square rooting both side, right? Now you just need to solve this. You just do the cross multiplication. Okay, so 0.15 minus x equals to 2x. Now this will come on the other side. So 2x plus x equals to 0.15. Okay, or 3x equals to 0.15, or x equals to 0.5 meter. 0.05 meter. Don't make this mistake, very common mistake to make. Okay, 15 divided by 3 is 0.05 meter. You can use the calculator, so you can find the calculator. So the distance is 0.05 centimeter from the smaller charge. In case they particularly mention what is the distance from the larger charge, then what you have to do, you have to find this one, 0.15 minus 0.05, that is 0.1 meter from the bigger charge. So So this is very important to mention. If you don't mention, 1 mark will be deducted. So here the answer is 0.05 meter from the 0.2 microcoulomb charge, or you can mention for smaller charge as well. So this is very important to mention from which charge you are measuring the distance, because distances will be different for two different charges. Okay, easy question, solvable question. Let's move on to the next question. A conducting sphere of radius 10 cm has an unknown charge. If the electric field 20 cm from the center of the sphere is 1.5 into 10 to the power of 3 Newton per coulomb and points radially inward, what is the net charge on the sphere? So we again I told you this is based on Gauss law. Okay, we have a sphere, radius is 10 cm. Okay, we can convert it into meter later on. Has an unknown charge. Okay, the charge is unknown. Sorry, inside the sphere, obviously not outside. Inside the sphere some charge is there. Okay, no matter where it is located, as long as it is fine. Okay, if the electric field 20 cm from the center of the sphere, so electric field 20 cm from the center of the sphere is 1.5 into 10 to the power of 3 Newton per coulomb and points radially inward. Okay, so this is not actually about Gauss law, this is just simple easy problem. So radially inward means the electric field is along in this direction. Okay, electric field value is given this value. So what is the net charge on the sphere? So how to do that? Electric field is basically given by KQ by R square. For outside points outside the sphere, electric field is given by KQ by R square. So what is K? 9 into 10 to the power of minus 9. Now one more thing, don't do it right now. What we are trying to find? We are trying to find the charge Q. So Q is basically E into R square divided by K. That will be easier to solve. So what is the value of E? E is given 1.5 into 10 to the power of 3. R is given 20 centimeter. 20 centimeter means 0.2 whole square. Now remember that here R will be 20 centimeter. The radius of the sphere is not important. Only fact is this distance is greater than the radius. That is the only thing that we require to know. Other than that, there is no purpose of this radius. Okay, divided by 9 into 10 to the power of 9. So just do the square, 1.5 into 10 to the power of 3 into 0.04 divided by 9 into 10 to the power of 9. Okay, so this is the charge on the sphere. It will go up and you will get the value, you will get minus 6.67 nanocoulomb. Now why it is minus, you have to solve it. Okay, using the values, no worry, you will get this value. Now why is this negative? You have to remember that the electric field was radially inward. So for radially inward, the charge must be negative. Q is negative for inward electric field. Right, Q is negative for inward electric field. So based on that, you can easily calculate what will be the actual electric field in this case. Now let's move on to electric potential and capacitance chapter. A lot of questions based on capacitor are coming from this chapter. Calculate the potential at point P due to a charge of 400 nanocoulomb located 9 centimeter away. Okay, so first we have to find the potential. Previously we are finding electric field, now we are solving potential. Potential, trust me, is very easy. So charge is given 400 nanocoulomb and we are trying to find potential located 9 centimeter away. Okay, how to do that? So electric potential is basically given by KQ by R. So in case of electric field it was r square, in case of potential it is kq by r. Here you have to apply the sign, whatever charge they have given to you, don't worry, just apply the sign of the charge is important here. Nanocoulomb means 10 to the power of minus 9, and 9 centimeter is given. 9 centimeter means 9 into 10 to the power of minus 2, and there is no square. There is no square in this case. Okay, 10 to the power of minus 9, 10 to the power of 9 cancelled, 9 cancelled. This goes to up, it will become 400 into 10 to the power of 2, that is 4 into 10 to the power of 4 volt. Okay, 4 into 10 to the power of 4 volt is the potential. As simple as that. Very simple question. Obtain the work done in moving a charge of 2 nanocoulomb from infinity to that point P. Okay, now you have a charge located at infinity, okay, and you are trying to bring that charge from here to here, and they asked you what will be the work done. The work done is basically given by charge times the potential at that point. Charge into potential at that point. Okay, or potential difference basically. The ideal formula should be potential difference. Now if you know that potential at infinity is basically 0. So what is the potential difference? Potential difference is final potential minus initial potential. For the 2 nanocoulomb charge who started at infinity, okay, he is coming, so initial potential for that is 0. At infinity potential is 0. Final potential when it reaches here at this given point, the potential is Vp. Right, at this point potential is Vp. So from here you can calculate the work done, basically Q into Vp. What is Q? Q is so this is say Q test charge. So let me just don't confuse. So Q test charge is 2 nanocoulomb, 2 into 10 to the power of minus 9, and Vp is 4 into 10 to the power of 4. That will be equals to 8 into 10 to the power of minus 5. So this is volt, this will be joules. Remember that unit of work done will be joules. So this much work you have to do to bring the charge from infinity to that point. So 8 into 10 to the power minus 5. Now the last part says does it depend on the path? Because electric field is a conservative field. Electric field is a conservative field. So it is independent of the path. So conservative field does not depend on path, only a non-conservative field, for example friction, in that case it depends on the path. Gravitation, electric field, magnetic field, path is not important. Next question. Capacitance of a parallel plate air capacitor is 1 nanofarad. So parallel plate capacitor, the capacitance is given by 1 nanofarad. Okay, and the plates are separated by 2 millimeter. So nanofarad means 1 into 10 to the power of minus 9 farad. Okay, plates are separated by 2 millimeter. Millimeter means what? Millimeter means 2 into 10 to the power of minus 3 meter. Don't forget to convert the units. As I said multiple times, find the area of each plate of the capacitor. So you have to find the area of the each plate of the capacitor. Okay. Now how to do that? We know that capacitance is basically now there is no dielectric, so air capacitor means epsilon naught A by D. Okay, this is the formula. So you have to find the A. So A is basically C into D divided by epsilon naught. Okay, now what is C? C is given 1 nanofarad, that is 1 into 10 to the power of minus 9. D is given 2 into 10 to the power of minus 3. And what is epsilon naught? 8.85 into 10 to the power of minus 12. Okay, if you put those values, you will get, it will be 2 divided by 8.85 85 meter square. Okay, you can calculate the exact area. It will come out to be 0.226 meter square. So it will be 0.226 meter square. Okay, this is the step, simple question. Okay, this kind of question might come in a 2 marker question as well, 3 marker questions as well. So be careful, and very important style of questions where capacitor dimensions are used to calculate the values. Two charges of 10 nanocoulomb and 10 microcoulomb and 5 microcoulomb are 12 centimeter apart. Find the work done in bringing the charges 2 centimeter closer. So we have two charges, Q1, Q2, and initial distance was 12 centimeter. Initial distance was 12 centimeter. Now if you bring them closer, okay, no matter which charge is coming which side, now the distance now is 10 centimeter. What is the work done in this process? Another simple question if you know how to solve it. So first you have to find the potential energy of the system at the beginning. Potential energy of the system at the beginning is basically, what is potential energy? This is potential energy at the beginning. Initial potential energy. Initial potential energy is K Q1 Q2 by R1 squared. So this is R1, this is R2. So once they are coming 2 centimeter closer, the new distance is 10 centimeter, right? 12 minus 2, 10 centimeter. This is the initial potential energy. And what is the final potential energy? Final potential energy is basically K Q1 Q2, there is no R square. There is no R square divided by R2. Okay, so now put the values 9 into 10 to the power of 9 into charges are 10 microcoulomb, 10 into 10 to the power of minus 6, and 5 microcoulomb, 5 into 10 to the power of minus 6. Initial distance 12 centimeter, 12 into 10 to the power of minus 2. Okay, as I said, centimeter to meter, this is the easiest way. Now can I cancel anything? I think not. 3 4s are 12, 3 3s are 9. Okay, I can cancel one more, 2 5. So 5 5s are 25, 75. So it will be 75, 12 plus 7.5. You can use the calculator to find it. So it will be 3.75. Okay, 3.75 is the so this will be potential energy. Since we have potential energy, it will be joules unit. Now what is the final potential energy? Final potential energy will be 9 into 10 to the power of 9, 10 to the power 5, 10 into 10 to the power of minus 6 into 5 into 10 to the power of minus 6 divided by 10 into 10 to the power of minus 2. So in this case 10 10 cancel. Okay, 9 in a 5 9 is 45. 45, it will be 4.5 joules. Okay, 4.5 joules. So what is the work done? So work done is basically change in the potential energy. Change in the potential energy. So UF minus UI. So that is 4.5 minus 3.75, that is, it will be 0.75 joules. Okay, so answer is 0.75 joules. Okay, next question. The following diagram, the value of each capacitor is equal to 3 microfarad. Find the equivalent capacitance across AB. So we have to find the equivalent capacitance across AB. Each of them has the value 3 microfarad. So this is 3, this is 3, this is 3, this is 3. Now if you see that, first we will start how they are connected. If you see that these three 1, 2 and 3, they are connected in series, and this is connected, this is suppose fourth one, then they are connected in parallel to that. So 3 capacitors connected in series. How to find the equivalent capacitance? So we can draw this diagram like this. This is an intermediate capacitance, say C1. This is C. Now all of them are three capacitors, all of them are 3 microfarad. So what is the value of C1? C1 is basically series combination. So series combination you cannot calculate normally, so don't confuse. This is a capacitor, so 1 by C1 equals to 1 by C plus 1 by C plus 1 by C. C is 3 microfarad. Right, so 3 parallel capacitors connected in series. So this is the formula, right? So 1 by C1 is equal to 3 by C. So C1 is C by 3, that is 3 microfarad by 3, that is 1 microfarad. Now these two are connected in parallel, so the final equivalent capacitance is C plus C1. Parallel combination means simply adding, so 3 plus 1, that is 4 microfarad, as simple as that. Okay, answer is 4 microfarad. Now next question, this is the last question from this chapter. Two capacitors of capacitances 2 picofarad and 4 picofarad are connected in parallel across 100 volt supply. So two capacitors, 2 picofarad and 4 picofarad connected across a 100 volt supply. This is the symbol for capacitance, this is symbol for battery. I hope you are aware of that. If you have even opened your book at least once, you should know that. Are connected in parallel across 100 volt supply. What is the total capacitance of the combination? Total capacitance is simple. So in this case, series parallel combination. So parallel combination means equivalent capacitance can simply be added. 2 plus 4, that is 6 picofarad. This is the equivalent capacitance. Now what is the total capacitance of the combination? Determine the charges on each capacitor. So charges will not be same because they are in parallel combination. So suppose this is Q1, this is Q2, the total charge is Q. Now what we know that if we replace this with equivalent capacitance, if we replace the combination with the equivalent capacitance, same battery, same combination, everything else is same, okay, then the charge in the circuit will be capital Q. Okay, so this is C equivalent, this is V. Okay, so if we replace it, the same charge will pass. Now also we know that from the conservation of charge, Q is equal to Q1 plus Q2, right? Q1 is equal to Q1 plus Q2, and also we know that the voltage across each of this capacitor will be same. Voltage across each of the capacitor will be same. Okay, so voltage across Q1 is 100 volt, voltage across Q2 is also 100 volt. Why? In parallel combination voltage remains same, in series combination the charge remains the same. Okay, so from capacitor 1, anyway this formula, this is not required in this case, just for your information. So Q1 is equals to, what is Q1? Q1 equals to C1 into V. What is C1? C1 is 2 picofarad. Pico means 10 to the power of minus 12, and V is 100 volt, so it will be 2 into 10 to the power of minus 10 coulomb. And what is Q2? Q2 will be 4 into 10 to the power of minus 12 into 100 coulomb, that is 4 into 10 to the power of minus 10 coulomb. So these are the two charges, simple. Okay, so 6 picofarad is the charge, and answer is given. You can write this as 0.2 nanocoulomb. So you divide it with 1 extra 10 and make it 10 to the power of minus 9. You can answer this as 10 to the power 9 nanocoulomb, but that is fine. If you leave the answer here also, you will get full marks. Okay, 0.2 nanocoulomb, 0.4 nanocoulomb, it is little looks better, otherwise this is also fine. Now we are moving into alternating current. A series LCR circuit contains a pure inductor of inductance 5 Henry, a capacitor of capacitance 20 microfarad, and resistor of resistance 40 ohm. If the AC source is of 200 volt, 50 Hz is present in the circuit. Find the impedance, also find the resonant frequency of the circuit. Now in AC related problems, you can, as I told you in your PU board exam, you are allowed to use simple calculators. So calculator use is very, very important, because the values are not always super pretty, okay, because there is involvement of pi, and secondly it is sometimes it comes in the division as well. So that is why the calculator usage is important to find the values. Without using calculator, generally it is difficult to solve without using calculator. So first step number 1, you have to remember this steps, okay. So what is the first step? It is an LCR circuit. Yes, LCR circuit. So first step is step number 1, XL, calculate XL. Step 2, calculate XC. Step 3, calculate Z. Okay, so these are the 3 steps when you are calculating the impedance. Okay, and resonant frequency is basically, there is a resonant frequency, formula is simple, 1 by 2 pi square root of LC. Okay, this is the formula for resonant frequency. So these are the steps you have to remember. If you remember the steps step by step, follow it, all AC problems can be solved along with slight knowledge of the theory. Okay, so if they ask you in what is the angle, there is a formula for angle as well, we will see that. But other than that, small amount of theory knowledge, and the steps are almost same for all the problems. First we will calculate XL. What is XL? XL is 2 pi FL. Also, in rare occurrences they might give you the omega also, but 99.99 cases I have seen the frequency is given angular frequency. If they give angular frequency, that radian per second, or angular velocity in radian per second unit, then you can use this formula. If it is given in 50 Hertz unit, then always this is the formula. So 2 into 3.14 into frequency is 50, and frequency, and 99.9% cases frequency is given 50 only. Okay, and inductance is given 5. Okay, so 5 into 2, 50 into 2 is 100, 100 into 5 is 500, and this is 3.14. so it will be I think some 1600 something. Okay, exact values I am not calculating, you can calculate it. That will be the exact value of this XL. Now what is XC? XC will be 1 by 2 pi FC. Exact values you calculate. Okay, I am not going to calculate the exact values, I will give you the final answer anyway, but you have to calculate the exact values using your calculator. I don't have any calculator, so I cannot solve it. Okay, as I said, these problems require calculators to solve. Okay, other than that, these problems are very, very simple, straightforward, step by step process. Frequency is given here 50 Hertz, and the capacitance is given. One more careful about this, capacitance generally given in microfarads. So microfarad means 10 to the power of minus 6. Okay, microfarad, picofarad, nanofarad, whatever they will give, you have to be careful, you have to add that part. Okay, now this 10 to the power of minus 6 will move up and it will become plus, divided by 100, 200 into 3 is 628. Okay, 628. So whatever value you will get, that value you have to show whatever is the value of XC. Okay, I think somewhat around 400 or 500. Okay, so you can calculate the exact value whatever is the XC. Now the impedance is very simple, it is given by R square plus XL minus XC whole square. That is the general formula. Now if after solving this XL and XC, if you see that XL value is less than that of XC, then you just need to switch. outside there is a square term, so it will not matter if you switch XC and XL, right? But we will always try to do it bigger number minus smaller number. That is the strategy. Okay, so you have to calculate XL and XC, and based on that you can calculate what is the Z value. Okay, Z value you can calculate using this formula. And second is also find the resonant frequency. What is the formula for resonant frequency? As I said, resonance frequency is 1 by 2 pi square root of LC, that is 1 by 6.28 into square root L is given. What is the L? L is 5, C is 20 into 10 to the power of minus 6. So this is the part where student makes mistakes because of this calculation. Okay, because of this calculation student make mistakes. So there is no other problem in this problem. Okay, so 520 is 100. So frequency is, so I am continuing here, so let me mark it. Okay, 1 by 100, that is a 6.28, sorry. Okay, sorry, I just erased the question by mistake, but I will try to give you the solution anyway. So frequency is basically given by 1 by 6.8, 1 by 6.28, 1 by 6.28 into 5 into 20, that is 100, into 10 to the power of minus 6, that is 1 by 6.28 into 10 to the power of minus 4, right? 100 into 10 to the minus 6, so that will be 1 by 6.28 into 10 to the power of minus 2. Square root of minus 4 plus 4 does not matter, it will always be half of that value. Now minus 2 will go up, obviously minus never stays below, so it will go up and it will be 10 square by 6.28, or it will be 100 divided by 6.28, okay, which is closely same as 16 Hertz. Okay, so the resultant impedance is 1412 ohm and the frequency is 16 Hertz. An AC source of frequency 50 Hertz is connected in series with an inductor of 1 Henry, a capacitor of 90 microfarad and a resistor of 100 ohm. Does the current leads or lags the voltage? Calculate the phase difference between the current and the voltage. So first of all, again, step number 1, what I said, step number 1 is calculate XL. So we will follow our strategy. What is XL? XL is 2 pi F into L. Okay, 2 into pi is 3.14, F is 50 Hertz, L is 1 Henry here, right? So 5 2s are 10. sorry, it will be 50 Hertz, not 5. 50 into 2 is 100. So 100 into 314 is 314. So 314 ohm is the XL. Okay, so XL is 314. Now once you have calculated XL, this is not done yet, you have to calculate XC as well. So 1 by 2 pi FC. So what is C here? 2 pi into 2 into 3.14 into F is 50, and it is 90 into 10 to the power of 90 microfarad, 10 to the power of 6, minus 6, sorry. So it will be 10 to the power of 6 divided by 90 into 100, 9000 into 3.14. Now if I remember it correctly, it will be 35 ohm. Okay, obviously I cannot calculate it like this, I have to use a calculator. If I remember it, it will be 35 ohm approximately. So basically, so this is the first part. If you calculate this much, you will get 1 mark, 1 mark, 2 mark is done. Third mark is basically where who is leading or lagging. Basically current is leading or current is lagging. So if XL is greater than XC, which is in this case, okay, current lags. So in this case current lags. Okay, current lags the voltage. If it is opposite, that is XC was greater than XL, then it would be current leading the voltage. Okay, so to current to lead, XC must be greater. For current to lag, XL must be greater. Okay, now what is the phase difference? Formula for phase difference is tan inverse of XL minus XC divided by R. Now remember that this formula again depends on whether XL is greater or XC is greater. If XL is greater, XL minus XC. If XC is greater, XC minus XL. Okay, only fact is current leads or lags, that is the value. Okay, same thing, whoever is bigger, that has to sit first, whoever is smaller, that has to sit next. So XL is 314 minus 35 divided by 100. If you calculate the value, you will get the answer to be 70 degrees. This will come out to be tan inverse. If you are not able to calculate the tan inverse, if you leave the answer here 2.79, that will be sufficient. But if you somehow can find the value, 70 degrees would be nice to have. But 70 degrees is not a standard angle, so obviously this is not a standard value as well. So this will be the answer if you solve it. Okay, so current lags the voltage and the value is given by 70 degrees. Now next question, a sinusoidal voltage of RMS value 200 volt and frequency 50 Hz is applied to a series RC circuit which R is equal to 3 ohm and C equals to 800 microfarad. So here we have only R and C. What is the meaning of R and C? We have R and C, and also if you notice that so far we have solved so many problems but we have not drawn any circuit diagrams. So circuit diagrams are optional in this case, not super required. Okay, but if you want, you can draw it in every case. Okay, teachers will be very pleased. So sinusoidal voltage of RMS value 200 volts. So RMS value is 200 volt, the input voltage. Okay, frequency is given 50 Hz. Most cases the RMS value so far whatever we have solved, the voltage was not required at all. Applied to a series RC with R is 3 ohm and C is 800 microfarad. Impedance of the circuit. So how to do impedance? There is no L here, but capacitance is there. So definitely we can calculate XC. XC is 1 by 2 pi FC. Okay, this step is common. All the problems, be it RL circuit, RC circuit, whatever they have given you, you have to calculate this. 2 into 3.14 into 50 into 800 microfarad. So I know that microfarad means this. 10 to the power of minus 6 first stage you have to write here, then you have to calculate here, and whatever value you will get, I am again it will be 10 to the power of 6 divided, I think I can solve it, 100 into 800 into 3.14. let's see. So 1 2 3 4 zeros, 4 zeros will cancel, so that means 100 divided by 8 into 3.14. so it will be equals to almost 24 25, close to 25, that means 4 ohm. Okay, XC will be close to 4 ohm. Okay, if you use the calculator, you can calculate the exact value. Now what is the impedance of the circuit? What is the impedance? Now there is no XL here, so either you put X equals to 0 or you completely ignore XL and you have to use this R square plus XC square. Simple. Okay, there will be always square root. Now what is R? R is 3 square, XC is 4 square, so it will be 5 ohm. Okay, 3 square plus 4 square, square root is 5 ohm, right? The current through the circuit. Now you have to find the current. What is current? Current is basically VRMS divided by Z. Okay, Ohm's law, but in a new form here. Basically instead of R you have to use the Z. So VRMS is 200 and then you have to divide it by 5. So 200 divided by 5, that will be 5 4s are 20, 40 ampere. This is the current, right? Next is phase difference between current and voltage. Now again XL is not there, so phase difference will be simple. Phase difference will be XC by R, that is the phase difference, that will be equals to tan inverse. XC is 4 by 3. 4 by 3 means it will be 53 degrees if I am not mistaken. This is standard tan inverse 4 by 3, not super standard, but if you are preparing for competitive exam, that comes out to be the angle. Yes, so it will be 53 degrees is the angle of phase difference. So 5 ohm, 40 ampere, 53 degrees. This is a very standard problem, and all the values are given such a way you can calculate them without using calculator as well, right? Now next question, a resistor of 50 ohm, a pure inductor of 250 millihenry and a capacitor are in series in a circuit containing an AC source of 220 volt 50 hertz. In the circuit, current leads the voltage by 60 degrees. Find the capacitance of the capacitor. So if you see, resistance is given, L is given, frequency is obviously given, and then the phase difference is given. They asked you find the capacitance of the capacitor. You have to calculate C. So first step, XL. First step again, XL. What is XL? 2 pi F into L. Okay, so 2 pi 2 into 3.14. Again I am just showing you the steps. Final calculations is up to you, okay, because I don't have any calculator. So 250 millihenry. 250 millihenry means 250 into 10 to the power of minus 3. So be careful, this is millihenry, okay. So 100 into 250 into 3.14 into 10 to the power of minus 3. Why I am writing 100? Because 2 into 50 is always 100, right? So this 1, 2, 3 zeros are cancelled with this 10 to the power of minus 3. So you can say 25 into 3.14. That will be very close to 75, but it will be more than 75 because there is a 0.14 term is also there. I think 77, if I am not mistaken, it will be 77 point something. Okay, now this is XL. Now what is the phase difference? So phase difference is given by 60 degrees, which is equals to tan inverse. Now which is leading? Current leads. Very careful, current leads the voltage. Current leads means XC must be greater than XL. Okay, so this is the part where it says leads. So in the previous problem where we solved, it said that current lags. If current lags, then it is XL minus XC. If current leads, then it is XC minus XL. Okay, and the angle was given 60 degrees. So tan 60 is basically XC minus XL by R. What is tan 60 is? Tan 60 is sin 60 divided by cos 60. Sin 60 is root 3 by 2 divided by half, that is, it is root 3. So root 3 equals to XC value we don't know, XL value we have calculated almost 77, R value is 50. Now simplify. So 50 root 3 equals to XC minus 77. So XC is 50 root 3 plus 77. So that is why I said this problem requires calculator, but steps are only mathematical, not super complicated physics related calculations are there. Now this is not over. Why not over? Because we know that XC is basically 2 pi F into C. So this is not over. You will get some value over here. Okay, whatever value you will get, you have to put that value. So C will be equals to 1 by 2 into 3.14 into 50 into this whatever value you received here. So using that formula you can calculate C, and the value will turn out to be 20 microfarad. It will be 20 into 10 to the power of minus 6 farad, which will be equals to 20 microfarad. Okay, you can calculate it and let me know if you find anything different answer. Okay, deal. Now next question. A sinusoidal voltage of peak value 220 volt is applied to a series LCR circuit in which resistor of resistance 5 ohm, a pure inductor of inductance 32 millihenry and a capacitor of capacitance 800 microfarads are connected. Find the resonant frequency, calculate the impedance and power dissipated at resonance. So this is the most commonly asked question, but this is the most easy question amongst all the problems that we have solved. How to do that? First, resonant frequency. So we do not need to use the step 1, step 2 in this case, because they have directly asked our last step, that is resonant frequency first. So resonant frequency is 2 pi square root of L into C. That is 1 by 2 into 3.14. L is given by 32 millihenry, 32 into 10 to the power of minus 3, and capacitance 800 microfarad. So I need a little bit more space. So it will be 1 by 2 pi 2 into 3.14 into square root of L is 32 into 10 to the power of minus 3, H is 800 into 10 to the power of minus 6. Okay, so now what we have to do, we have to carefully cancel the zeros first. So this is just about mathematics. Okay, 6.28, 32 into 8, let us separate. This will be basically, we will try to see if we can square root of these two numbers. Okay, now 10 to the power of minus 3, then we had 2 zeros here and we had minus 6 here. So 10 to the power of minus 6 minus 3 plus 2, right? These 2 zeros here. So minus 9 plus 2 is, it will be 10 to the power of 7, minus 7. Right, so it will be 1 upon 32 into 8 is what? 16 to the 32, 16 into 16. So it will be 6.28 into 16 into 10 to the power of minus 7. Okay, so this is the resonant frequency. You can use the calculator, and one more thing, you don't need to do it like this. What you can do, you can take this 10 to the power of minus 7 in the upward part, so you will be left with, so resonance frequency is square root of 10 to the power of 7 divided by 16 into 6.28. Now 10 to the power of 7, this is not an even number, so 10 to the power of 7 can be written as 10 to the power of 3 into square root of 10. Right, so what we have done, we have divided it into 6 plus 1, so 1 remains inside the square root and 6 comes out of the square root and becomes 10 to the power of 3. So this is the way you can simplify this and use your calculator to find the final frequency, which is 10 to the power of 3 into square root of 10 divided by 16 into 6.28 Hertz. This is the frequency. You need to do one more step, and then calculate the impedance and power dissipated at resonance. Very, very important. So impedance, so if you see that I have filled the entire board to calculate the frequency, I have only very small space left, and entire part B will be done in that part only. So impedance at resonance is basically nothing but the resistance, that is 5 ohm. Okay, impedance at resonance is just 5 ohm. So what is the power dissipated? Power is basically V square by Z, V square by R, V square by Z. So V is given to 20 volt whole square by 5. Okay, you will calculate this. So this will come out to be 10 Hertz approximately. Okay, and this will be coming out to be 4840 watt. Okay, this will be the answer. Very simple. So this part is the simplest part, and answering this part you get 3 marks. Impedance and power 2 marks, and calculating the frequency you get 3 marks. Okay, now ray optics. An object is placed at a distance of 40 centimeter from a concave mirror. So concave mirror, we have solved concave mirror problems a lot in our class 10th, right? If you remember, if you have solved, if you have not solved, then you have to, this is the time to solve. An object is placed at a distance of 40 centimeter from a concave mirror of focal length 15 centimeter. So focal length is 15 centimeter. Okay. If the object is displaced through a distance of 20 centimeter towards the mirror, how much distance the image has displaced? Okay, the object placed as 40 centimeter. Initially it was placed as 40. Okay, focal length is 15 centimeter. Okay, it is displaced 20 centimeter towards the mirror, so final distance is this. So this is 20. That means the final displacement will be also 20 centimeter. How? Because this must be this 40 minus 20. So the final distance is also 20 centimeter. So how much distance the image has displaced? So first case, we have to find the first image distance. Case number 1. So what is the image equation? 1 by V plus 1 by U equals to 1 by F, or 1 by V equals to 1 by F minus 1 by U. So this is first we will try to find the formula itself so that we can use it for the both cases. So 1 by V equals to U minus F by UF, or V equals to UF divided by U minus F. This is the common formula that we are going to use. Now for case number 1, U is minus 40 and F is minus 15. For concave, everything is negative. Mirror length, no matter what, concave focal length is negative. U is negative by default. So for all types of concave, focal length is negative. If you read concave, you will know focal length is negative. Now put these values over here. So V equals to UF, U is minus 40, F is minus 15 divided by U minus F. U is minus 40 minus F, so plus 15. Okay, this is V. So it will be in the numerator it will be positive 40 into 15. Denominator will be negative, so negative sign will come up and it will be 25. So 5 5s are 25, 3 5s are 15, 5 5s are 25, 5 8s are 40. So it will be minus 24 centimeters. So initially it was minus 24 centimeter. Now concave mirror produces real images. That is why the object distance turns out to be negative. In the second case, in the case number 2, okay, the new object distance is basically you have displaced it towards the mirror. So minus 40 minus 20, that is minus 20 centimeter. Okay, this is the new object distance. Focal length is same, that is minus 15 centimeter. You have to find the image distance, that is V equals to minus 20. We are using the same formula that we have derived here in this case. Okay, minus 20 minus 15 divided by minus 20 plus 15. Okay. So from there minus minus cancels, this there will be a negative sign here that will come up. So to minus 20 plus 15 is 5 and it will be 20 into 15. So it will be 3 5s are 20, that is minus 60 centimeter. So the displacement of the image is delta V. Delta V is 60 minus 24. Sign is not important. Just only we need to find the displacement, which will be 36 centimeter. Okay, 36 centimeter is the answer. So if you solve step by step, not a super difficult problem, okay, but a lot of formula signs you have to remember to solve such questions. But there are incentive is that mathematics is generally simpler, okay, you can solve even without using calculators, but the difficult part is that you have to remember the sign convention. For U is negative, F is negative for concave, okay, and solving the equation. So these are the pros and cons from this chapter. An object is placed at a distance 0.3 meter from a convex lens of focal length 0.2 meter. Find the position and nature of the image formed. Also find the distance through which the object should be moved to get an image of linear magnification -1. Convex lens, focal length 0.2 meter, position and nature of the image formed when the object is placed at a distance 0.3 meter. Okay, so we have convex lens, focal length 0.2 meter. It is placed at a distance 0.3 meter, which is slightly on this side, so object is placed here, the distance is 0.3 meter, okay, and you have to find the position and the nature of the image. So how to do that? Lens equation, from lens equation 1 by V minus 1 by U equals to 1 by F. Okay, again first stage is to simplify this so that we can simply put the values to solve it. So UF U plus F, so V is basically UF by U plus F. Okay, while applying formulas, do not apply sign convention. Sign convention will come after you have simplified it. Now you have to put the values. So what is U? U, as I said, always negative, that is 0.3 meters. Focal length for a convex lens, convex mirror, is positive, that is 0.2 meters. So now what is V? V is UF U into F, sorry, divided by U plus F. U plus F. So there will be a negative from the top, negative from the bottom, so they will cancel. So 0.3 into 10 to 0.2 and divided by 0.5. Okay, so you can remove one of the decimals from the top and bottom. So 0.2 into 3, that is 0.6 divided by 5. 0.6 divided by 5 means 0.12 meter. Okay, so the image distance will be 0.2 meter, 0.12 meter. Okay, now the second part of the question says that also find the distance through which the object should be moved to get an image of linear magnification -1. So linear magnification -1 happens when the object is placed at 2f. Okay, when the object is placed at 2f, you get equal and opposite image on the other side. So that is why the magnification is -1. So you have to mention that linear magnification -1 happens when the object is placed at 2f, right? So the new U will be -40 centimeter, right? U should be 40 centimeter, twice of that f, right? So what is the displacement? Displacement delta U is 40 minus 40 centimeter. No, because we are using meters, let me use meters only. 0.4 meters. Okay, 0.4 meter is basically 40 centimeter. Anyway, so the delta U will be 0.4 minus 0.3, that is 0.1 meter. So the object must be displaced by a distance of 0.1 meter. And as you can see, I think there was some mistake here. It will be 0.12. Okay, this will be 0.12, not 0.6. 0.6 divided by 5, right? Now well, yes, correct. I made a mistake here. No one of you told me, right? So this will be 0.2 plus minus, so it will be minus 0.1. okay, so 0.1 definitely one decimal will cancel, so it will be 0.6 only. Yes, okay, it will be 0.6 only. Now 0.6 meter is the V. Now and it will be a real image. Why it will be a real image? Because as you can see, the sign of the V is plus, that means it's a real image, real and inverted in fact. So because they have mentioned that size and the nature of the image, you have to mention real and inverted to get the full marks, otherwise 1 mark will be deducted here. Now next question, a small bulb, a point source, is placed at the bottom of a tank containing water to a depth of 80 centimeter. What is the radius of the circular surface of water through which light emerge out? Refractive index of the water is 1.33. So we have a tank, okay, some water is there, and not draw it like this, it will be difficult for me to later explain. Some water is there and we have a light source here at the depth of 80 centimeter. Okay, so light is here and they told you that the refractive index of water is 1.33. so refractive index of water is 1.33. now what we have to do, we have to find the circle that it will form on the surface. Why the circle will be formed? So as we know that as the light is traveling from water to air, the light ray will bend from away from the normal, and slowly after some time it will be falling at a critical angle. At the critical angle, the refractive angle will be 90 degrees, right? So this will be, suppose say theta c, this will be theta c. So after that, whatever light will fall, that light will reflected back into the water again. Okay, so that means you will get a circle of this radius. This will be the radius. Okay, this will be the radius and you have to calculate this radius. How to do that? So first of all, you have to calculate the angle theta c. Okay, so if this angle is theta c, incident angle here, the same angle will be here as well. And then what? Then we can calculate this angle as well. This is a normal, this is normal, means this angle will be 90 minus theta c. Okay, and then you can use the trigonometry to calculate this height. This is given, you this angle you have calculated, you can find this distance, right? Now how to solve it? First we will use the fact that sine theta c equals to 1 by n. Okay, so sine theta c is basically equals to 1 by 1.33, right? And we do not need to calculate theta c. Okay, scientific calculators are not allowed, so you cannot directly calculate sine theta c, that is fine. What we will do, we will try to see how this angle and this is related. From there we can find. So if this is theta c, this is theta c, as I said, this is 90 minus theta c. Now this is suppose this is angle, so this is base, this is perpendicular. Perpendicular by base is basically, perpendicular by base is tan theta. R by this distance, say this distance is d, R by d is tan, is equal to tan 90 minus theta c, right? So this will be cot theta c, right? So this is how we were going to solve it. Even if we do not know exact value, we can still solve it. So R is basically d cot theta c, that is 80 into cot theta c means what? Cos theta c divided by sin theta c. Okay, so just a desi upay to solve this question. 1 minus 1 point Now cos theta is 1 minus sin square theta, that is 1 by 1 minus 1 by point whole square divided by 1 by 1.33. so if you calculate it, you will get it 91 centimeter. If you can find it directly from this method, fine, and otherwise you have to remember this is the formula, this is how you solve it. This question came in 2024 final exam. Okay, so even though the problem is simple, you need to remember a lot of physics and some trigonometry to solve this question. Okay, so that is why I recommend 4 chapters for you to solve. If you want, if you are not super confident with the theory part of optics, you can skip this chapter, but then you have to solve all the 3 chapters. Okay, 2 lenses of focal length. So for example, this is a very simple question. 2 lenses of focal length 0.2 meter and 0.3 meter are kept in contact. Find the focal length of the combination. Calculate the powers of the 2 lenses and combination. So we have 2 lenses contact in combination. One is focal length 0.2, another is 0.3. Okay, find the focal length of the combination. What is the focal length of the combination? We know that 1 by f is equal to 1 by f1 plus 1 by f2 when 2 lenses are in combination. That is f equals to f1 f2 by f1 plus f2. Okay, so f1 is 0.2 0.3 divided by 0.2 plus 0.3. So it will be 0.06 divided by 0.5, so that will be 0.6 by 5, that is 0.12 meter. So this is the power, this is the focal length of the combination. Okay, what is the power of the combination? Power of the combination is simple, 1 by f, that is 1 by 0.12. It is given in meters. So in case of power, basically and both of the focal lengths are positive, right? Focal length sign is not mentioned, so what type of lens is not mentioned, so we can directly take sign. Okay, so we can say this is plus, and the unit of power is diopter. It will be 100 divided by 12 diopter, which will be around 8, I think, right? 8 point something diopter. Okay, 8 12s are 96, so it will be 8.33. okay, so this is a very simple question, and this is also from one of your previous year question, not recent, but 3-4 years ago this question also came. A prism of angle 60 degree produces a angle of minimum deviation of 40 degrees. What is the refractive index? Calculate the angle of incidence. So this is basically based on the formula that mu equals to sine A plus delta m by 2 divided by sine A by 2. Okay, prism angle is given 60 degrees and angle of deviation is given 40 degrees. Okay, so you have to calculate the refractive index first. So refractive index is basically sine 60 plus 40 divided by 2 divided by sine 60 by 2, that is sine 100 by 2, that is 50 divided by sine 30. Now this is an approximated value. Sine 50 is very close to sine 53, so I am approximating that value will be 4 by 5, and sine 30 is half, so it will be approximately, okay, not correct, 8 by 5, that is 1.6. okay, this is not the exact value, you can calculate, if you can calculate, that is fine. Okay, 1.6 is the refractive index. Now what is the calculate the angle of incidence? How to calculate the angle of incidence? So to calculate the angle of incidence, we have to we know that at angle of minimum deviation, the angle of incidence, both angles are same, right? right? So if suppose the angle of incidence is I, then angle of refraction is R, okay, then after that it emerges with the same angle E, and this will also be R. E is equal to I. So this much we know, that for minimum deviation, that is delta M, R1 equals to R2 say equals to R is basically A by 2. This information we know. Okay, if you have solved the theory part, you already know this is the formula. So, and I we are trying to find, mu we already know. So sin I by sin R is basically mu, right? So what is sin I? We don't know. Sin I equals to mu into sin R is sin 30. Okay, in fact you don't need to put the value, exact value or this value, you can start from here only in this case. So mu is sin 50 by sin 30, that was the value, right? We approximated that, so this will cancel. So sin I is equal to sin 50, so I equals to 50 degrees. Okay, nice problem, but not super simple, but not super difficult either if you solve it. So instead of getting 1.6, you will get 1.53 if you put exact value of sin 50. I got an approximated 1.6, which I feel I am satisfied with. Okay, 10% errors are allowed, so based on that I can say I will get full marks. Are you? If you are practicing, you will get. Now this is a bonus question from your model question paper, one of the model question paper. In this question, the question is from dual nature of wave and matter. So that is why I thought maybe if they give you the question. So this is a standard question. I will teach you how to solve questions from this wave nature of light in through this problem. This is a standard problem. Answer is also very standard. Even if you don't know the calculation, even if you don't have the calculator, if you do the step by step, and finally if you write the answer, you will get the marks. So when a light of wavelength 400 nanometer is incident on a photosensitive surface, the stopping potential for the photoelectron emitted is found to be 0.96 volt. When the light of wavelength 500 nanometer is incident on the same photosensitive surface, the stopping potential is found to be 0.34 volt. Calculate the Planck's constant. Okay, Planck's constant, which is a constant. So how to solve any questions from photoelectric effect in general? The main equation that you are going to use is that sometimes you might need to find the K max, that is kinetic energy max, or sometimes you will use stopping potential. Okay, both are same by the way, and that is equals to H nu minus phi. Nu is the frequency of the wavelength used, and phi is the threshold frequency. Sometimes we will use threshold frequency, sorry, it is work function, it is not threshold frequency, work function. Sometimes we will use this as like this, which is basically threshold frequency. Nu naught is threshold frequency. Okay, so this is the main equation from this chapter, and all the problems that might come will be based on this single equation alone. But there is no guarantee that there will be a question from this chapter, but this is the only equation that you need to know to solve questions from this chapter. Okay, now what we will do first, we will calculate first case number 1. Say the stopping potential is V1 in this case, and in this case what we will do, because the wavelength is given, we have to replace it nu by C by lambda. That is optional based case to case basis, because lambda is given, nu is C by lambda, so we will use that. C by lambda 1 minus phi. Okay, this is the first case. Second case is EV2. This is case 2. Okay, we are using a different lambda, lambda 2 minus phi. Okay, so we will just subtract it. First, before doing anything, we just subtract it. We will get E V1 minus V2 equals to H C 1 by lambda 1 minus 1 by lambda 2. Okay, phi cancels. That is the main objective. You have to eliminate the phi. Now E is, so what is the value of V1 minus V2? Lambda 1 minus lambda 2, everything you have to calculate, but our main objective is to find this constant H, Planck's constant H. So from this equation we can write H is equals to E into V1 minus V2 into 1 by lambda 1 minus 1 by lambda 2, no. So the entire thing will go in the division. So that is basically C into 1 by lambda 1 minus 1 by lambda 2. If you are not confident like this, you can put the values and then also you can calculate. But because there are a lot of 10 to the power of minus involved, because the Planck's constant is very small value, so that is why I am doing it this way. So what is E? E is 1.6 into 10 to the power of minus 19. So up to this step, if you solve, you will get almost 3 marks. So what is V1? V1 is 0.96 minus 0.34. Okay, these are all given. What is C? C is 3 into 10 to the power of 8. What is lambda 1? Lambda 1 is 1 by 500. Sorry, lambda 1 is 1 by 400 nanometers. 10 to the power of minus 9. Minus 1 by 500 into 10 to the power of minus 9. Now here I am trying to solve this in a separate way so that it becomes easier for me to put the values. It is, otherwise it will go on long enough. So 1 by 400 into 10 to the power of minus 9 minus 1 by 500 into 10 to the power of minus 9. So this 10 to the power of minus 9, all of them will go up and become plus. So 10 to the power of 9 divided by 400 minus 10 to the power of 9 divided by 500. Now again these two zeros can be cancelled, right? So 10 to the power of 7 will be common. 1 by 4 minus 1 by 5. Okay, LCM will be 5 4s are 20, 5 minus 1, so 10 to the power of 7 into 1 by 20. Okay, and 10 to the power of 7 can be written as how to write? 10 to the power of 5 into 100. Okay, this is a style. So I have just taken 2 zeros and kept it here, so they will cancel. 5 20s are 100, so it will be 5 into 10 to the power of 5. So this will be 1.6 into 10 to the power of minus 19, and the division will be 0.62. Right, 9.96 minus 34, so 9 minus 3 is 6, and 6 minus 4 is 2, so 0.622. So it will be 3 into 10 to the power of 8 into 5 into 10 to the power of 5. Okay, so if you solve everything using your calculator, definitely you will get 6.6 into 10 to the power of minus 34 joules second. Very important. If you see similar questions, you have to write the unit for the Planck's constant. Without writing the unit, you will lose 1 mark. Okay, so final calculation is simple. This problem is simple, that is why I chose to solve it. Only difficult part is to navigate through this part. If you reach up to this point, then you can directly write this value. If you don't reach up to this point, you cannot write the direct value. The marks will be deducted. After writing this, you cannot write it directly. So you have to at least simplify it so that you can use your calculator at one step to calculate it. Okay, so that is the basic thing answer is already known answer to us, but unit is important because it is a Planck constant. And here we have reached the end of this entire lecture. It is turned out to be less than 2 hours. So I hope you enjoyed this session, and if you want anything else, please don't forget to mention that in the comment below. I will be back with all level 5 derivations tomorrow. Till then, bye.